Sample problem number 10-05. A solid sphere rolls without slipping along a track shaped as shown at right. It starts from rest at point A and is moving vertically when it leaves the track at point B. At its highest point while in the air, will it be above, below, or at the same height as A? So we can quickly go to a couple things. It's not going to go higher. To go higher, it'd have to find some source of energy, so they could have a gravitational energy that's higher. So the potential answers are the same height or less. I'm going to just draw it in for a moment, and without prejudicing things too much, I'm going to draw it here and say there's going to be some height coming out. And the question is whether that height is equal to or less than the original height. So here's our way to think about it. When it gets to its highest point, it no longer has a vertical velocity, but it is still spinning. Like this. It's still spinning because at the moment that it leaves the ramp, friction stops acting on it. So there's no torque on the ball, and so whatever angular momentum it had, it maintains. So it still has the same omega. But that omega is going to consume some of the energy because there's going to be 1/2 mv square plus 1/2 I omega square plus mgh. And although this is 0, this is not. And sorry, this shouldn't say kinetic energy, this is the total energy at the end. And then the total energy at the start was, of course, just mg big H. And since friction acts only to maintain the rolling without slipping but does no work, then the total energy is conserved. So we know that energy at the start is energy at the end. So mg big H is some number 1/2 I omega square plus mg little h, and since this is consuming some of the energy, this must be less. So we have our truth statement here is that mg capital H is greater than mg little h, and we cancel the m's and the g's, and we find that capital H is bigger than little h, which means that it will be below the original height.